Coulomb's Law. Objective: to introduce Coulomb's law of electric force between two charged particles. Coulomb's law states that a charge exerts upon another charge a force that is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. Let the two charges, Q1 and Q2, be kept at a distance r in a free space. From Coulomb's law, the force on Q2, F, is directly proportional to Q1 into Q2 and it is inversely proportional to r square. On combining the two relations, we get F is directly proportional to Q1 Q2 by r square. By removing the proportionality, we get F is equal to K Q1 Q2 by r square. K is a constant of proportionality. K is independent of the charges or distance between them. It depends on the medium in which charges are kept. From experiments, the value of K for free space is found to be 8.98755 into 10 power 9 or approximately 9 into 10 power 9 Newton meter square per Coulomb square. The constant K is often written as 1 by 4 pi epsilon naught. The constant epsilon naught is called permittivity of free space. Its value is equal to 1 by 4 pi k, that is 8.8542 into 10 power minus 12 square coulombs per Newton square meter. Coulomb's law can be written in a vectorial form as F equals to K into Q1 Q2 by R square R cap. You can observe that if Q1 and Q2 have same polarity, the force between them is repulsive and force on Q2 due to Q1 is in R cap direction. If Q1 and Q2 have opposite polarity, they attract each other and force on Q2 is in minus R cap direction. For example, in Bohr's model of hydrogen atom, an electron revolves around the nucleus in the first orbit of radius 0.53 angstrom. Let's calculate the attractive force between the nucleus and the electron. Hydrogen nucleus contains one proton whose charge is plus 1.6 into 10 power minus 19 coulombs and the charge of electron is minus 1.6 into 10 power minus 19 coulombs. From Coulomb's law, the magnitude of attractive force between the nucleus and the electron in a hydrogen atom is approximately equal to 82 into 10 power minus 9 newtons. Let us compare this electric force with the gravitational force that exists between them. Mass of the proton is 1.6 into 10 power minus 27 kilograms and mass of the electron is 9.1 into 10 power minus 31 kilograms. From Newton's universal law of gravitation, the gravitational force between the particles is gravitational constant into mass of the proton into mass of the electron divided by square of the distance between them. This comes out to be around 360.85 into 10 power minus 49 newtons. This is around 10 power 40 times less compared to the electric force that exists between them. This is the reason why gravitational force is never taken into consideration in the study of structure of atom. Coulomb's forces follow the law of superposition. According to this principle, force upon a charge due to a second charge is independent of the forces due to the other charges in the vicinity, or the resultant electric force on a charge is a vector sum of the individual Coulomb's forces. We can understand it better by looking at the following example. Three charges of magnitude 10 microcoulombs, 20 microcoulombs and 30 microcoulombs are kept at the vertices of an equilateral triangle of side length 1 meter on the xy plane. What is the electric force on the charge at vertex A? From Coulomb's law, force on A due to B, FAB is equal to 1.8 newtons and it is towards x direction. Similarly, force on A due to C, FAC is equal to 2.7 newtons and it is at an angle of 60 degrees with x-axis. From the principle of superposition, the resultant electric force is the vector sum of these two. The resultant force on A is equal to root over 1.8 square plus 2.7 square plus 2 into 1.8 into 2.7 into cos 60 degrees, which equals to 3.9 newtons. This resultant force makes an angle tan inverse of 2.7 by 1.8, that is 56.3 degrees with the x-axis. Summary. According to Coulomb's law, electric force between two charges Q1 and Q2 separated by a distance r is equal to k Q1 Q2 by r square, where k is equal to 1 by 4 pi epsilon naught and its value is 9 into 10 power 9 Newton meter square per Coulomb square. Epsilon is not known as permittivity of free space.